we're not saying that Bitcoin needs to be upgraded. We're saying that Bitcoiners need to be upgraded. Like, we need to change the way we think, and we need to change the way we act, and we need to finally understand what Bitcoin is. This problem has been going on for 17 years. It's like, all we're trying to do is objectively look at Bitcoin for what it is as a physical process. And we think that anyone who does this should arrive at the same results that we do. And if you don't, let's talk about it. Let's figure this out. Like, we're not saying that this answer is done. Like, this paper is literally just the beginning.
Having gone through this, I am beyond excited to have this conversation because there has been thousands of hours of deep thinking that have gone into this. Oh my God. I can't wait for the folks, listening to this to be able to dig deeper into the actual paper. But for anybody that's hearing this for the first time, the paper that we're going to be discussing is called Bitcoin, the Architecture of Time. The subtitle here is the thermodynamic and mathematical object of time, entropy, and measurement. Guys, where do you want to kick this off? Like, what is your 3-sentence compression of this topic for the listener who's tuning in and saying, what in the world are they about to talk about?
If I was to start, I would simply put it, I think this is the answer that Bitcoin is physics. And so this paper will bring us into the domains of exploring energy and time itself.
I love it. Nick?
As well as memory.
Yeah.
I think that we can at least say that Bitcoin provides a new lens for us to look at what we've thought we've seen in physics for a long time and kind of give us a new language to reference to kind of fact check ourselves and everything we've discovered since this project of knowledge started.
Jeff, people were probably thinking, why is Jeff Booth on this call? What's his role here?
Or people know how much reading I do, how much thinking I do. And when I'm stuck on something, I just continue to go down the rabbit hole. And the same reason took me down Bitcoin, same reason many people went down the road of Bitcoin. And physics is something I've been stuck on for. So physics generally has been 2 different models of physics that don't work together for 90 years and a whole bunch of theories that can't make them work together. So when Jack and Nick first brought this paper to me, you can imagine that you too, Preston, I know this is true. We see a lot of information and we see a lot of stuff that might not jive with what we believe. And it forces us to, okay, could this be true? And looked at deeper. So when Jack and Nick first showed me this paper, and how long ago was this? Almost a year?
Probably about a year ago, yeah.
There was something in it that grabbed my attention in one of the most profound ways ever. Right. It was still a nugget and everything else. And they've been working on it for a long time, but it wanted me to dig in.
You guys talked to me about this, 6 months ago? And we had a conversation and the paper was probably 150 pages at that point. And where are you guys at now?
We're still in the process of finalizing the editing here. But, when we release the podcast, we're landing about 224 pages right now.
This is a book. This is a book. And
it's a lot of information.
There's not fluff in this. Like, let me tell you, folks, and when you go through this, you're just going to kind of be like, oh my God.
But I think that's the part, Preston, which is going to set up a challenge. Yeah. Because if the ideas in Jack and Nick's paper here are correct, and it feels like they are, it rewrites everything. Mm-hmm. And so that's a big, big kind of ask, and you'd have to have evidence based on that. So it's not the depth, the number of words in the paper. Now, mind you, that's enough in itself. It carries such huge implications that it forces you to pay attention.
Yeah. Yeah. And the reason I want the audience to kind of realize this isn't something that you guys just like banged out over the weekend. Like, this is something you guys have been thinking about and piecing together for, like Jeff said, over a year.
I want to make a note on that, Preston.
Yeah.
We're going to get into some deep physics. And so, like, when you're talking about the quantum world, everyone likes to talk about entanglement. It's like, we are entangled in ways that you cannot perceive. It's like your podcasts have been instrumental in some of our thinking here and what has led us to this point. So it's like the thought has preceded 2020, like when you initially brought Michael Saylor onto your podcast, that was one of the moments where I was like, okay, somebody's beginning to speak like the language that I see in my head. It's like, I had this inclination that like Bitcoin is energy and time, and there was no way to like properly express this. So it's like listening to you has brought us to this point today. So it's like we're seeing this, this representation of how the past is beginning to interact and build the future to where we are. And so we couldn't be here without you and without the Bitcoin community. Like everyone has played a role in this paper. Just because you don't meet the people who might hear your words, your actions like are directly influencing the future here. And I can say that that's how this paper kind of become, what it was.
Yeah, I would say that, yes, we've engaged within this past year, but the journey kind of doesn't have a clear, timestamp of like, oh, it started at this point. It's been the culmination of just like listening, hearing, and understanding different viewpoints within what we call the Bitcoin community and also outside of the Bitcoin community, going back to formal academia frameworks and just like trying to take it all and make sense of it when you lay it all out. But yeah, like you two have said things that are embedded in the thinking of trying to just explore these ideas, because we're trying to lay out an answer, but it is fundamentally an exploration. So this is an exploratory paper in the sense of we're just trying to make sense of all of the logical pieces as it comes to us.
So your paper opens with what feels like a Gödelian problem, which is physics treats time as a continuous parameter, but we can't step outside time to test whether that's true because we're made of that. Can you explain this self-referential problem? Why has it been invisible for so long? And just kind of like where the paper kind of starts off with this.
So I guess I would start, the problem that Gödel like introduced is incompleteness. And, when you begin to dig and use Bitcoin as your reference to understand incompleteness, you realize that incompleteness is formally defined by the lack of a boundary. And so like mathematically, that is expressed through Bitcoin's 21 million cap. And so we really want to hit on the point here that like the novelty of Bitcoin is the 21 million cap. And so that thinking needs to be extended outside of just money. It needs to be extended to physics and logic itself. And so like when you're talking about mathematics here, it's like any number that's divided by infinity is zero. And that is your definition of meaninglessness. It's like the mathematical form of meaninglessness. And so when you begin to put together like what is incomplete here, it's actually the lack of boundary in our mathematics. And so the idea is that like we take Bitcoin as to be like the truest form of knowledge that we can hold on to. Like it literally persists indefinitely. Every block is literally persistent forever for as long as we know. And so we have always approached this as like this object, this ledger is some formal structure that needs to be applied to further thinking here. And so when you think of it, it's like if we are a product of time, or if we are, everyone calls it like the Planck tick of time here, it's the smallest known unit of time where the theory of time breaks down. And so if we think of that object as simply like equivalent to a Bitcoin block, we exist within that block. And so we cannot exist outside of its formation. And so when you're trying to measure time itself, when you're trying to measure the block, if you are a fraction of time, you cannot actually reference like its creation because the process precedes your cognition. And so it's like a computer bit trying to understand the computer that it resides in.
This idea of Planck time, it literally makes my skin crawl when I'm reading this. It's such a fascinating parallel to Bitcoin and Bitcoin blocks. In the paper, you say Planck time is invoked as a formal limit, but can't be probed. Why not? What's the barrier? Why can't we probe Planck time? Because I'm just not an expert in that domain. I'm sure the physics person.
I mean, in general, like the public understanding is this is just where our physics breaks down. This is the point in which, quantum and classical physics like converge, and then we don't know. So like right now it's been open-ended, where it's basically, we don't know if reality and time is continuous or discrete past this point. It's just that we don't know. And that's what Planck time as this limit represents in our current understanding within the frameworks of physics that we've inherited.
I think we need to back up a little bit before Planck time and such for an audience that doesn't understand the difference between the standard model of physics and quantum physics. And I have a really simple analogy to use there to say kind of what I find the challenge. So anything under 10 to the minus 28 power, small, very, very small things like photons operate differently than big things. So if you took a photon in the double slit experiment, many people have heard of the double slit experiment that kind of fully grasp what it means. If one photon hits two slits without an observer, that photon goes through both slits at the same time. But as soon as you introduce an observer to that experiment, that photon only goes through one of those slits. And this has been proved over and over and over again, and we have evidence of this reality. But that doesn't look like, and how could that reality match with a reality that we observe every day that is potentially made of that reality, which would mean we're part of that reality being formed, but it doesn't feel like that in the macro sense. Then those models don't line up. Did I explain that in a fair way to be able to say, what is the problem with these two models that don't merge together?
You've explained it in a fair way in terms of the reference that we do have. Like, this interpretation is presented to us many times, but I think in all honesty, it's an imperfect representation of what we're observing, because remember, the photon itself is a model of something that we don't fully comprehend. Like, the photon is our best placeholder of an object that's not just an object. It's also a behavior. It's also a wave, right? So it's a wave-particle duality. So how can this thing be two things simultaneously? What else exists in nature that behaves like that? We're talking about the finest resolution. It's the thing that allows us to measure everything else. And we're trying to probe and say, what is that thing? And why do we see its behavior in such the way that it seems probabilistic, and we see it in many places, when you scale up and you zoom in on or zoom out on reality, we don't observe photons like that. We don't observe photons at all. Photons are what allow us to perceive anything at all. So the distinction of classical is like, we're not perceiving objects in the same way when you look at the micro world versus the macro world. And I think what we're doing in the micro world is we're not actually perceiving objects. We're trying to apply an objective framework to it, but it's actually, we're observing processes that lie outside of our ability to observe. And then we're trying to timestamp it, put a package around and say that's a thing versus that's a process playing out and we're observing it.
The analogy that immediately comes to mind for me when I hear Jeff and Nick kind of talk there, when you're looking at Bitcoin, is prior to a block being found, you're saying that there's this infinite array of addresses that could transact with each other. But until you actually observe the block, you don't know what actually transpired between addresses, right? And then it's like you were saying earlier, Nick, it's memory. It's in the past. It's happened. And when you observe that block, you can say, oh yeah, this address transacted with that address. But if you're looking at what's going to happen in the future, there's literally an endless array of transactions that could happen. And so is this the bridge that you guys are seeing in very layman's terms? Because I'm telling you, the paper folks goes into way more evidence from a physics standpoint of like how these two are correlated, or, it's a very simple model that we can look at that's maybe representative of our own reality, right? Is that it? Or is there more that you would like to kind of, from a very top level standpoint, point out to the listener so that they can kind of understand more nuance?
So one of the main ideas that Nick and I have been going back and forth on in terms of how we can think about this complex topic through the lens of Bitcoin is we landed on the UTXO model of reality, which is we're taking this UTXO model that we can all observe and understand, and we're trying to map that backward to our physical reality. And so, like you said, I wanted to correct one word. You said an infinite set of states. Everything in Bitcoin is bounded. Even the future is bounded, because in Bitcoin, the future can only be determined by what exists in the past. So you only have a finite amount of UTXOs that could ever transact in any given block. And it is a very large, but we have to say it is a finite set of futures. It's just unknowably large, it's probably incalculable large. And so we're looking at this as like the potential. Whatever exists in the mempool can be thought of as pre-time. And so I guess we're going to have to take a step back here, because the problem in physics is the axiom of continuous time. And so with continuous time, physics doesn't have an answer to what a measurement is. The current best guess is that the observer is the measurer. And Bitcoin gives you a different perspective. In Bitcoin, anything in the mempool does not exist. It's only referential to its past state. The UTXO that was mined in the past exists, but this future transaction does not yet exist. And only when a valid nonce is found does the block collapse, or does the measurement occur. And so the measurement occurs first. It is an objective answer to what has happened throughout the network. And only after the measurement has occurred can you observe the structure. So we want to separate the two, like there's measurement and there's observation. And so observation would be simply verification of structure, which is looking at what is like objectively true post this block of time. And so we want to separate those two things, because if we think about our existence as existing inside the ledger, like we are inside of these blocks. Somehow this consciousness that, of life has evolved to the point where we have cognition inside of these blocks of time. And so we're looking at what is. And so in physics, when they're observing something, they're really verifying it. The difference is because they have no definition for measurement itself. And so they have conflated the two as, when I look at this thing, that is the measurement, and it's what they call the observation. But Bitcoin says when you look at it, you are verifying it. You are not creating that block. You are simply observing it and verifying it. So Bitcoin gives us like a way to distinct between the two, these two forms. And so like we can dig more into like what that actually means in terms of a discrete process of time. But objectively, like the problem in physics that we would say is it's continuous time. And that has forced physics to import like an external form of measurement that they can't define. In Bitcoin, the measurement is internal, like the block of time, the tick of time is the measurement. And so in Bitcoin, time is defined in like numerous ways. It's defined by the rule set. So it's like the rules that exist before measurement. It's defined as the process. So the act of measuring. So this would be the act of mining and traversing the nonce space to find a valid nonce. And once you have a valid nonce, you have a measurement. And that measurement results in a block. And then the time is now an object. And so you've gone from energy to object, or energy to memory. And that memory is like the lasting form of time itself. And so when you order blocks in a chronological order of how they've unfolded, that is what physics understands as the coordinate of time. And so we're seeing multiple dimensions of time that do not exist in physics that we can observe in the universe now, because we exist within inside that time that's producing. And so like Bitcoin provides us a different perspective. We stand outside of the time that Bitcoin produces. Like we don't exist inside Bitcoin. We are the constructors or the architects of Bitcoin's time. We are the decisions that go into the transactions, the people that mine the blocks, and the blocks are the outcome of our work and our actions. So we exist on the other side of the boundary here. We are observing time from the outside. And so to wrap up the point, it's like we want to make it clear that like both are objective understandings of time. One is the internal perspective and the other is the external perspective. And you need both sides of the coin to actually understand what time is.
That was insane.
Love that. Just love that.
In the initial part of what you were saying, you're talking about how it's relative to each other. And I immediately think of Einstein and his theory of relativity. And in that, you have space-time, right, is the big thing that was just groundbreaking, about 100 years ago. So in your paper, you introduce time-space as a replacement for space-time. And in time-space, time is the primary axis, the ordered sequence of thermodynamic commitments. And space becomes the derivative. This inverts how physics normally thinks. It's the opposite of that. So why is this, I think for the listener, they hear all that and it sounds like fancy jargon that you guys inverted what Einstein's space-time is. But like, why is that important? Is it that you're saying that time is an emergent property of a blockchain, or creating a fair system in which
Well, in this
Nobody can control
context,
the clock.
before getting to that, it's not like, oh, Einstein was wrong. It's more like if you observe it for what it is, you realize it's almost like a linguistic problem.
Mm.
And so time space is a reference of simply inverting what you're prioritizing mentally to construct your mental model from. Because again, space-time is more of like a general term to describe the connection between time and space. And we think of time as a fourth dimension instead of something inherently different. And so the way that we look at it is you have the 3 dimension of space, and time is actually not a fourth dimension per se, but almost like the mirror of space itself. And so if you could see it from the other side, you can look at time differently. And so we see time as the foundation, the constraint rule set that allows space to construct itself, like spatial order, causal order. And so we look at time as basically what needs to be the preceding rule sets to allow the causal order that we observe as our spatial environment. So we see it as the flip side of space itself. And so again, instead of thinking space first and then time is this thing we append to it, it's just simply we're trying to say, okay, well, let's start with time itself. Could time be the place where if it has a defined rule set and it was allowed to play out in these discrete steps where something is evolving over time, then we can begin to see what we, describe and observe as our spatial environment. So it's just trying to invert the way that we've been inherited almost like a bias.
So Preston, I think that if you go back to Einstein too, why was he able to see that idea of space-time when nobody else could?
Mm-hmm.
And when you look back at it, where he imagined himself on a beam of light,
Mm-hmm.
right? Moving at the speed, and everything was relative to the speed of light. He imagined that. And that was outside. Why I think these are important or very, very interesting things to challenge our minds is everybody else was in a box measuring what they thought reality was from within that box. What he did is he stepped outside of the box and he imagined, what if this existed, right? And this was the speed of light, and I was traveling at the speed of light. What would that change to this box?
Mm-hmm.
What I think this paper is that,
Mm-hmm.
right? What if this probability space that is we can observe in the mempool, right? You have this probability space that takes energy and converts that energy into information.
Mm-hmm.
That direction, that one-way direction, creates time, and time is emergent from that same thing.
Mm-hmm.
If that were true, would force us to challenge a whole bunch of the ideas that we were stuck in this other box. And so, Jack or Nick, would you guys comment on that?
I have some things to add. So Nick and I have talked about this. We want to make it pretty clear that this is not our theory. This is Bitcoin's theory. We're just trying to observe Bitcoin for what it is. And we believe that Bitcoin is something way more fundamental than probably the average person believes it to be. And so we're trying to map that thing that we're observing onto our reality and seeing if that allows us to unlock something new here. And so we've jumped around a lot, and I really want to hit on the point. It's beneath this subjective protocol, we're just trying to say that there's an objective physical process underneath it that maps directly onto physics. And like you said, it is the process at which I would refer to it as we take the non-space and difficulty, we'll quantify that as entropy, and we'll do work to resolve a single valid nonce from this, we'll call it a large space for the average listener. And in doing that, that creates work. The resolution of a valid nonce from a sea of invalid nonces is work itself. And that work is applied to the block. So it's you have work generated from the nonce, and that work is applied on the block. And so that is kind of the structure of the process, beneath Bitcoin. And so we're trying to quantify the energy. That was the original goal here, was to get outside of any fiat referential system here and just look at Bitcoin base as a physical transformation. And so that's the base level. But one thing that I wanted to add to that in terms of, you said you brought up time space, is that we kind of have to take a step back here and just say, objectively looking at Bitcoin, like what is a block? And we see a Bitcoin block as time itself. And so this Bitcoin is empirical evidence that time may be quantized. So when you look at the block itself, it is indivisible temporally. It's all or none. There's no valid half work. There's not even a valid half hash. It's like the hash is quantized, the block is quantized, the value units are quantized, and time is quantized. There is no
every aspect is quantized. That's just the observation we've made. Every aspect is quantized. And so the other system, not every aspect is quantized. And this is the initial thing we're observing and then trying to map and make sense of.
Which goes back to your original comment at the very beginning, which was boundary layers and being able to, right?
There's a boundary every step of the way.
Everything has a boundary, including time. And that is fundamentally, that's major for physics, because all of physics right now relies on this assumption that time is continuous, because there has been no proof prior to that there could be an alternative. People have theorized that, like people like Stephen Wolfram have begun to work on these ideas. And so like, we think he's really close to what we see, but we think he's missing Bitcoin. And Bitcoin is the instantiation of what he's working on. It's like the proof needs a network. It needs to be filled with energy. It's a proof that needs to prove itself, to put it in like layman's terms. But when you look at the block, you can't break it up into smaller temporal components. Like at layer 1, the block is the smallest unit of time. Like nothing happens between blocks. I mean, we know that lightning exists between there, and I don't want to go in there because, I mean, that's a whole different can of worms that this paper can unlock to, in terms of thought. But staying on layer 1, there's no time between blocks. Like the block is this quantized tick of time. And to bring it back to time space, when you look at what time is in Bitcoin, I think, Gigi wrote about time, I think it was like in 2020. And so everyone should go and read his piece about time as well. But, he talks about the map being the territory. And that's kind of philosophical for some people. And if I was to put it in more layman's terms, it's like time is memory in Bitcoin and the memory is time. They're both the same dimension. It's like the memory that's produced in the block is the time itself, and that memory is lasting. And so when you look at the dimensionality, it's time and memory are a surface that exists in a coordinate of time, which is just the block height. So it's like the block height is the coordinate system, and at each block height, you have this time memory component where it's like a sheet of memory where time equals memory. Like only in that discrete unit of time is that true. Every block is a different measurement. It's a different event. And so this is the process of understanding discrete time. And so I would kind of finish it here as like, if the block wasn't the measurement in Bitcoin and the ledger evolved continuously until somebody observed it and it became deterministic, it's like, how do you solve the double spend problem without a quantized measurement? And so if you really begin to think logically about Bitcoin, it's like without that stamping, that quantized stamp of like, this is time, there is no solution to the double spend. And so logically, Bitcoin could not exist if the time that it produced was continuous. And so here we are sitting at, this discovery of, we're just seeing like the time produced by Bitcoin is objectively quantized. And if that is, and here's my point, it's like, you realize that the quantization of time is the thing that produces the binary logic. And what does that mean? Physics says classical information. It means it's this or that. It can't be both. It can't be double spent. A UTXO in Bitcoin must be spent or unspent. The Satoshis are here or there. It can't be both. And if it was a continuous process, Bitcoin wouldn't function. And so we couldn't build any logic on top of the system without that quantized tick of time. And we know, looking at physics, that information becomes classical. And so we are looking at something that is quantizing time, creating binary logic. And Bitcoin simply just says, if it's not the tick of time, if that's not the measurement, then what is? And so like that question just leaves a lot of, open-endedness, but we take, the measurement as being the tick of time. And so all we've tried to do is apply that model backward to physics and try to rediscover, or not rediscover, but put together the same picture with a different process underneath it. Physics emerges from time. It's a derivative of time. So time is beneath everything that we experience.
And if we just like ground all that, it's just like, is this empirical evidence for one of the two options, which is time a continuous only process, or is time a discrete process? And we can at least look at Bitcoin as an isolated physical system that's running, regardless of what our opinions of it are, it's running. And every single block is an empirical piece of evidence for that truth. And we're observing it, and it's a discrete form of time. And so if that's the case, and on the other side, we don't know whether time is or isn't continuous or discrete, we can at least look and point at Bitcoin and say, well, we at least have one physical system that operates on a discrete process.
Guys, I want to get a little bit more granular on the paper because there's other insights that you have in this that are just amazing with respect to entropy. Okay. So we've been talking a lot about time and energy and that, but so you identify a fracture that's persisted for over a century, and that's the Boltzmann entropy counts microstates in phase space. And then you have Shannon entropy, which, we've covered Claude Shannon on the show a couple times. Shannon entropy counts uncertainty over symbols. There's no operational bridge between bits and joules, which is what these two different theories are about. And so you're positing in the paper that there might be a bridge between these two. And this is the first time I've ever seen anything presented that suggests that there's a bridge, and you're using Bitcoin as, again, the model to kind of demonstrate that bridge between these two very profound ideas, the Boltzmann entropy and Shannon entropy.
This was one of the hardest problems for us to solve originally. Like this whole process this whole discovery of time was kind of a derivative of our initial inquiry. Like we originally started this paper just to measure Bitcoin in joules. That's what we wanted to do. And it led to so much more, and it demanded so much more because as we were kind of continually pulling on the string, just more and more of reality kind of began to reveal itself for us. And so looking at entropy in Bitcoin, we've never really had a process that kind of puts both together. And so like everyone says, Bitcoin's backed by energy. And so when you're looking at the construction of Bitcoin, like we have a 32-bit non-space, and we have some quantization of difficulty. Like difficulty is integer number of units. And simply put, like difficulty decreases the probability of a valid nonce in that 32-bit nonce space. So it's the frequency that a valid nonce will appear within that space. And so conceptually, we can think of that space as entropy. We can quantify it as entropy. And so when you're looking at the probability, the decrease in probability is the same thing as an increase in multiplicity. So for the layman, it's like you have a 32-bit space, and difficulty simply multiplies the number of those spaces that you need to search to find a valid answer. So like very simply put, you have a block of 32-bit or a box of 32 bits that you can kind of search for this nonce in, and difficulty just says you have to search that many of those 32-bit boxes on average to find a nonce. And so like we're trying to quantify entropy here. And so like when you're looking at the process of Bitcoin, it's you have entropy on one side, and then you have work applied to that entropy, and we'll call it happens under some temperature. Like we know hashing produces temperature, and the outcome is a block, which is some quantifiable amount of information. And so like we want to be clear here that when we're talking about the Shannon side, it's not the bits of physical information, like it's not the megabyte of the block itself. We're literally looking at the finite state space of Satoshis. We're looking at the configuration of these Satoshis because that is what is conserved through time. It's like as time progresses through blocks, the container around that is the 21 million cap. And so we have a system that started from 50 Bitcoin and is trending towards 21 million. And so each unit of time, the amount of Satoshis like existing in the system changes with each block. And so you have to account for that change. And so I might have drifted a little bit from what you asked, but Bitcoin just gives us these two processes. Objectively, mining produces heat in the form of Kelvin, and Bitcoin produces information in the form of a unique configuration of Satoshis in the network that you can measure. And so it's like you have both sides of this process known. Like we know the difficulty and we know the non-space before that. And afterwards, we know the exact block and the difficulty that it was mined under. Like we know all of this from beginning to end. And so the hardest part was how do we now relate these two things into one unified system? That'll go kind of deep. I don't know if you want to go there on in this conversation, because it's kind of going to Boltzmann's constant itself and how do we rethink through the ledger and how to redefine past variables in physics. So it depends on where we want to go here.
I think it's worth like going a little deeper there. I know we lose some of it. Don't you think, Preston? Just from
I would love to hear more on it.
Yeah.
So very simply put, like, again, the original goal was joules per Satoshi. The only equations that we had without making it up is the second law of thermodynamics, which gives us a relationship of temperature, internal energy, entropy, and it assumes constant volume and a constant number of molecules or of substance, we'll call it. And so when looking at like a Satoshi, like the Satoshi is the atomic unit of Bitcoin. Like the one Bitcoin of 21 million is like the quantum of value. And so this is what defines all value. And so it's imperative that that 21 million does not change. And so the Satoshi is the resolution that you can perceive that value. So it's how do we break that unit of one into smaller and smaller components? And so the Satoshi is the smallest unit of value that Bitcoin represents. And so when you look at the word Bitcoin, it's like that is what the Satoshi is. We call it a value bit. You can call it a Bitcoin, whatever you want, but objectively, it is a single bit of value inside that system.
I mean, it's tough. It's like there's three worlds and we've forever talked about two worlds. Again, you can think of the classical framework or the computational framework. We understand there's a domain of computational systems, and then you have physical reality. And these are two separate processes. So talking about Shannon is talking about mathematics and computation. And then talking about Boltzmann is talking about physical process, thermodynamics. And so what we're trying to talk about is this, again, bridge between them. That is, how does Boltzmann convert into Shannon? And then one makes this a real number objectively within the system that records it.
You asked, like, how do we bridge the two, right? And so it goes back to Boltzmann's constant. And so we wanted joules per Satoshi. And the only thing that relates entropy to energy is Boltzmann's constant. That's the only really known thing in physics here. And so we have to look at the dimensionality of Boltzmann's constant. It's joules per Kelvin. And so, and remember, like this whole process of applying Bitcoin onto the universe, it's like, what does the universe look like if Bitcoin or the ledger is its structure? And so we already kind of covered time earlier, but now we're going to cover like, what is 21 million? Like if the universe had a 21 million equivalent, what would it look like? And so objectively, like we're talking about a thermodynamic transition, like we're getting Satoshis in the block. And so we're looking for something that exhibits a similar behavior to Satoshis, but in the universe. And so it must be bounded. Remember, the boundary is the most important piece here.
I'm laughing because I see where you're going. This is crazy.
Yeah,
It's crazy.
It is crazy. Like it objectively is crazy.
I think it's like literally a truth we've just always taken for granted.
Yeah.
Absolute zero.
Bitcoin defines like the absolute zero and the absolute one. And what that really means is it just defines the boundary that you can define one and zero within. It's very complex. But going back to Boltzmann's constant, it's like what in the universe would be similar to that? Well, like we have Kelvin and we know that Planck energy has a limit. There is a limit at which physics says at Planck energy, or sorry, not Planck energy, I'm sorry, Planck temperature, the known understanding of temperature breaks down. And so like, what does that mean? It's like when you apply the ledger to it, it just means like nothing outside of this boundary can logically make sense. And so when you're looking at Bitcoin, it's the same thing as 21 million. Nothing outside of 21 million can have the ledger make sense. It's like once you exceed this number, nothing makes sense. And so we're not saying that Planck temperature is the temperature of the beginning. We're just saying that this thing represents what appears to be the equivalent of the 21 million boundary. And so when we multiply Boltzmann's constant by Planck temperature to normalize for this full boundary system, you can remove the domain of Kelvin. And so when you do that, you're left with simply joules. You have joules per Kelvin, and you multiply by Planck temperature, which is in Kelvin, you're left with joules. And when you do that, you realize you get Planck energy, which is what the physicists say is the energy of the universe. Well, through the lens of the ledger, it actually just says that this is actually a constant. If Boltzmann's constant is the relationship of entropy and joules, and we remove the domain of Kelvin from this equation because it's bounded, then we have this purely joules constant. And so I guess we have to take a step back here a little bit. And it's because we all think in absolute terms. Like our understanding of temperature is in absolute terms. Like we all know, sorry for the Europeans, but we all know water freezes at 32 degrees Fahrenheit, at normal conditions. And so we can think of that as a constant. And so when we apply this boundary of Planck temperature, it's actually a constant ratio. So I know I'm switching between Kelvin and Fahrenheit here. And the reason why we're using Kelvin is because it defines the absolute zero. It makes more logical sense. And so what do I really mean by that? It's like every unit of Bitcoin that you have or you perceive, you can always perceive it with respect to the denominator. And the denominator changes with time. Everyone thinks 21 million, and Nick and I have gone back and forth as, does 21 million exist now, or does it exist in the future? And objectively, when you're looking at it through the lens of thermodynamics, it exists through the future, but we can also say that it exists now in some sense. But all measurement must be relative to the boundary. And so now you're kind of getting into, we said the defining of absolute zero and absolute one. It's like when you take all measurement and put it against the boundary, you are only bounded between 0 and 1. You cannot exceed You cannot exceed 0 and 1. And so like, what is the most generally relative thing? I would call it the space between 0 and 1 in the most purest mathematical sense. And so when you're looking at Bitcoin, it's like, that's what you get. You get 1, you get 0, and everything that exists must be between those two things. And it all must sum up to 1. You can never exceed supply or the boundary.
Yeah, and so in Bitcoin, you see the rules that allow that assumption to hold true. Because again, we're saying 0 and 1 and the space between. But until now, that's literally an assumption that we've had to use, not an external physical system from us that enforces that truth every step of the way to make sure that truth holds at the end of the process the whole way through. And so to us, again, clearly the universe must hold that same rule somewhere within it. And so if not, how could the universe not have a symmetry of that?
Yeah.
It might be worth going into, because if this is true, there's zero risk of quantum attack on Bitcoin. It's an entirely different model, similar to a fiat model being able to provide value forever, right? Because, but would you dive into?
Yeah, let's pull on that thread.
Let's pull on that thread and drive, because it is literally an either or. They cannot both be true.
Explain why it's an either or, because I don't know that I necessarily understand that, Jeff.
So the reason why it's either or, it's like it's Bitcoin or it's quantum in terms of quantum computers. And the reason why I say that is because it relies on the ontology of time itself. Bitcoin literally wouldn't work if the blocks were just these continuous morphing thing. Like it needs to be discrete and quantized. So right there, we have some contradiction to this axiom of continuous time that all physics relies on. Like we want to make a note. It's like both general relativity and quantum mechanics both assume continuous time. And so if you pull that assumption away and say, no, it's discrete, we have to actually rebuild those theories from the bottom up again with this new understanding of time.
Jack, can I just keep going? But I just wanted to kind of, when you say continuous time,
yes.
If we were in continuous time, the question is, would we know it? Because essentially what you're saying is the idea of quantum, the very idea, this is the measurement of the discrete, of the tiniest unit. And we would never be able to observe that through our lens within it.
I think it's really ironic that, well, so if you do change the substance of time from continuous, and what we really mean by continuous is infinitely divisible, like you can just keep breaking it into smaller and smaller pieces. And Bitcoin says no, like at some limit, there's the block and you can't go any further. And
You
so,
must commit to a standard
A state.
measurement, a
Yeah.
global measurement.
And so like we perceive in seconds. And so this is some magnitude, like it's a ginormous magnitude of frequency of these fundamental blocks. But like you could think of Bitcoin in larger units of time as like multiples of blocks, like every 10 blocks, every 100 blocks is a frequency of time. But you need
Every
this base
difficulty
block
adjustment.
to even build what a frequency means. And physics believes that you can just keep dividing forever. And so if that assumption changes, going back to like the quantum question, it's like, how does that affect quantum computing? Because everyone is talking about like quantum as this inevitable thing that Bitcoin must bend the knee to, but Bitcoin actually is proving quite the opposite to our lens. And so the reason why it's binary is because the ontology of time matters. Like you can't double spend what is true about time. It's either quantized, discrete, and indivisible at some level, or it's continuous and infinitely divisible. It can't be both.
So,
And so-
but we have, just to push back a little bit on this idea. So we do have quantum computers that already exist. They're, microscopic in scale with respect to the number of qubits that they can perform at, right? Like I think from a logical qubit standpoint, we're like less than 30.
I think it's under 15, right?
Maybe even under 15, but it does exist. Would this be almost like a block reorder? I'm trying to think of the parallel in Bitcoin that would allow something like that to exist in a very small scale, but then never scale to a higher level. Would it be like a block reorg of time, that the parallel blocks were being found and then they get reorged and get definitized, so you could never like have something that has... I'm just spitballing here. I have no idea.
Preston, can I just jump in? Because I think we all might be crazy people in the same thing, right? But exploring this is part of the So my layman's version of that is you have all these probability states, and if you develop a logical qubit, then these probability states at the tiniest increment of time aren't actually coexisting. And as you expand the probability states, you get errors and errors on the other side.
Mm-hmm.
And so now you're building all of these error correction into the thing because you can't at the smallest, and they think in it, and you believe it can exist because you're not measuring time.
Yeah.
Right? Like we are not measuring time. We are approximating time. That is the distinction.
Yeah. So I would say it's not saying that like what they're observing is invalid. Well, they're observing something, right? And I think it's really what they perceive they're observing is different from what is actually occurring. Like they think something is happening, but fundamentally something else is happening. And it all depends on the ontology of time. And so I was saying it's Bitcoin or it's quantum. It can't be both. And what do I really mean by that? It's like when you ask the question, like if time is quantized and discrete, how do these models change? Like what changes? I don't want to go deep into the formalism because that's kind of getting outside of my domain of expertise here. But simply put, for like the listener, you can't take the derivative of, say, Schrodinger's equation if time is an integer. If at some level it's indivisible, then you can't take the derivative. And so the entire formalism would need to be reorganized to this change in time. And so like that is a whole different domain of physics. Like we are seeing a fracture in physics itself where there's the people who are appended to the continuous time and they're trying to make it work, and they keep hitting dead ends. And so like if time is really quantized and discrete, it's like they're continuing to work on the sinking ship. It's a sunken cost that they can't fix. Like the problem is the assumption, it's not what they're doing. And so you do have like other domains of physics where, like, say, we brought up Stephen Wolfram, like he is approaching physics from the other side, which is the discrete nature. But we need to look at like what actually changes when time is discretized. And so very simply put, like what is superposition or decoherence in a discrete time model? And so Bitcoin gives us that lens of what superposition actually is. It gives us an understanding of what physicists are actually observing when they call superposition. And that would be the mempool it's a pre-configured state of possibility, but it doesn't actually exist until it's measured. And this is like in the language of physics itself. They know like this is the pre-measured state. And when it's observed, it becomes measured and deterministic, but they don't have the process of how this goes from superimposed to classical. And so this isn't a substrate to actually compute on. It's a potential state. It's not a computable state. And so when time is discretized, the meaning of superposition changes because it is pre-time. And then when you're looking at decoherence, decoherence is the natural process of the measurement itself. And so it's like these words are all inverted. Like Bitcoin is actually saying no, like what physicists call as decoherence is actually really coherence. It's reality cohering to a single chain of events. They think this is a problem that you must engineer away. Like we need to maintain these superimposed states so that we can perform this computation. And oh no, like it keeps decohering to these classical states. It's like without that decoherence mechanism, like you don't have an objective reality. And so Bitcoin is simply just saying like, no, this is the process of time occurring, and they don't actually understand what they're looking at.
I'm somewhat speechless. It seems
Deep.
that if we do start getting quantum computers with 1,000 qubits or more, whatever logical qubits, that it would be almost an invalidation of this entire thesis. Would you agree with that?
Yes, and the goal is not to invalidate it. It's just trying to take the logic where it goes and just say, this is incompatible with the basically autopilot, perception of like, this is inevitable, this is going to happen, this is what quantum computers are going to do. Quantum computers are going to break all encryption, which is one of their primary fundamental use cases. And so if Bitcoin is literally, in our opinion, the definition of encryption at a global every state level, the conversation changes.
Yeah.
And right now, again, it's based on the ontology of time and understanding what is time. So that entire model has been built on, and ironically, we're talking about quantizing reality, and yet quantizing means to define like these discrete points where it's like, that's what we're saying it is. And yet time gets a pass, and by default, it's always continuous. How can that be the case? How can we say, yes, this type of science is meant to define everything in absolute terms, but time, that's continuous?
Bitcoin mining has a reputation for being complicated, risky, and hard to evaluate as a real investment. If you're considering mining in 2026, what actually matters isn't headline profitability. It's uptime, repairs, and whether the operation is run like a business. That's why I've been using Simple Mining. They're based in Cedar Falls, Iowa, and they run a white glove hosting operation where you own your own miners, choose your pool, and have Bitcoin sent directly to your wallet. They were featured on Inc.'s 5,000 list as the fastest growing company in Iowa with over 40,000 machines under management. What stands out is execution. They have the #1 rated ASIC repair center, and for the first 12 months, repairs are included. If mining margins get tight, you can pause with no penalties, and if you want to resize or upgrade your fleet, there's a marketplace to resell equipment instead of being stuck. To help people think through whether mining actually makes sense right now, they put together a short resource called the 2026 Bitcoin Mining Blueprint. It walks through the 5 mistakes investors make when allocating to mining and how to avoid them before deploying capital. If it sounds interesting, you can get it for free at simplemining.io/Preston. That's simplemining.io/Preston.
Yeah, like simply put, it's very ironic that to the listeners, it's like, go ask ChatGPT yourself. Like, don't trust me, but like, we want to make sure you ask the right questions. But it's like, if time is quantized and discrete, the entire formalism of quantum mechanics as we know it, like breaks. It just simply doesn't work. It would have to be rebuilt. And it's ironic that quantizing time breaks the system that was supposed to quantize everything.
So Jack, this is so big. It took me in the beginning, and it took Preston, because they're incompatible.
They are.
But just like, and I think this for the listener, if you were listening to some of the stuff on Bitcoin about the environment and how could you solve the environment from a system that must destroy the environment? If you ask a question about money, right? How could you solve any of those problems by a system? But the amount of money and nonsense and everything else inside that system, right? Because it requires that.
Mm-hmm.
The amount of money inside all of the researcher universities and everything else on quantum is going to attack this thesis like crazy, right? Because the power of everything comes from all,
which is the real signal, by the way.
which the power of everything comes from this thing, from that. And what we've learned in Bitcoin is over and over and over, the more you move into the system, the more individuals move into the system, the more you're just immune from this entire essentially thing based on a foundation of lies, right? That actually gets stronger and stronger by your participation in it. And so these two things are incompatible. And what I find interesting in this is our own agency inside this is being co-opted in the quantum because we don't trust ourselves in this. And there always has to be somebody else that's smarter.
Yeah.
Right?
And what does that mean if, again, like quantum physics, like theoretical physics, let alone just like quantum physics, but this domain, there are many interpretations, and those interpretations are actually proliferating over time. So we are seeing a fracture in like what is actually happening at these scales that we can't perceive with our own individual eyes. And then we have to default to experts who study those models for, the majority of their lives. And then we have to take on faith that what they're presenting back to us is what they say it is. And so is it possible that Bitcoin is this other model where you can get this more universal language understanding where anybody, no matter what institution you're a part of, can actually be observing and talking about the same phenomena without any specialized group who, if you're not part of, the in crowd, then you don't understand what's going on. And that's actually what I think is most exciting about this work is, like regardless of whatever profound insights at an individual level can happen, it's also just like, it's something that I think that over time is shareable with a wider audience than just the people that dedicate themselves to basically a path that was laid out way before, they came along, right? Like we've been on this model for 80 to 100 years in terms of, our theoretical physics. And again, there's never been a true alternative to that path. So it's just everybody working on it, like Jeff said, like all the money being plowed into it, it's already tied to an incentive that is separate from the theoretical physics itself. There's already a money machine behind it. So you realize that all of the information that's been shared with us over time, like you don't know what the error rate is, but you do know there is an error rate. And if you're not willing to perhaps question like how deep does the error go, then how can you truly know, like, are we living in a truthful system of knowledge around us?
Guys, what would be your closing comment to folks as they hear this whole conversation? What do you want to leave them with as they kind of put their phone down, take their AirPods out of their ears? What is the takeaway you want them to have?
I guess I'll go first. My message is like, if Bitcoin is quantized, or if Bitcoin is proof that time is quantized and discrete, we need to look at this quantum narrative for what it is. And that would be, it's simply an attack on Bitcoin that is masquerading as physics, operating through the lens of language and psychology. And so I would say, like, everyone, if you understand Bitcoin, you understand physics. Like, I want the physics community to answer, like, why is Bitcoin not an open source laboratory? Why is this not an open source experiment? It literally uses energy and creates an outcome. This is a process. This is a measurement. Why does it not suffice for the physics community? And so we need to just like look at what this narrative really is. It's like the narrative is Bitcoin is broken or it will be broken. We need to upgrade it. And until quantum was the narrative, it's like the old meme was like, hey, I'm new here to Bitcoin and I'm here to fix it. It's like, hey, I just read about quantum and I'm here to fix Bitcoin. It's like, it's the same thing. And so I would say, don't bet against Bitcoin and really don't assume the narratives that you hear to be true, and just simply try to go into into exploring this idea, because Bitcoin just says, don't trust, verify. And so it's like, who are you trusting with this information that, who are the people telling you that Bitcoin is broken? What is their incentive? What is their knowledge? It's like, if we don't actually understand this like base physical process beneath Bitcoin, like we risk misunderstanding like what Bitcoin is. And so like one point that like we didn't hit on that I think is very important. It's like, objectively, our conscious decisions precede the block. Our transactions and our decision to do work, and we call like the protocol itself, like all of that precedes the block itself. And so like everyone wants to talk about upgrading Bitcoin through protocol, and we're forgetting like the other half. Like Jeff, you always say, it's like, we are Bitcoin. And it's like, that's literally true. It's like the ledger is the map of our decisions. It is equally an imprint of our conscious decisions of how we value things, when we valued it, who we valued it with, and what was actually done. And it's simply just a record of that. And so if we have a bug in our mind, we have a bug in the ledger itself. Like the error that we perceive Bitcoin, like whatever we perceive it as, if that is like incomplete or wrong, then we are going to manifest that through our action. And so we need to be very careful here. It's like, we're not saying that Bitcoin needs to be upgraded. We're saying that Bitcoiners need to be upgraded. Like we need to change the way we think, and we need to change the way we act, and we need to finally understand what Bitcoin is. Like this problem has been going on for 17 years. It's like, all we're trying to do is objectively look at Bitcoin for what it is, as a physical process. And we think that anyone who does this should arrive at the same results that we do. And if you don't, let's talk about it. Let's figure this out. Like, we're not saying that this answer is done. Like this paper is literally just the beginning. It's just a tool to continue forward. Like there are so many, I said it to Jeff a long time ago, like this is a paper about boundaries, and drawing the boundary on the paper was the hardest part, because you can literally take any domain of knowledge and run with it, run with this idea, and everything changes if you change the ontology of time. And so it's like, if you want to, like a little call to action, it's here. It's like biology's waiting, chemistry's waiting. It's like, go and do it. Somebody, please.
All epistemology, all ontology, there's an opportunity to reassess all of them through the lens of Bitcoin. And so this is just simply meant to be a lens, but a verification tool for science, logic, and just our individual ability to objectively look at things without depending on, again, domains of knowledge that we inherited. I think what I want to leave people with is, if you don't think you have a fiat mindset, like I don't think you're thinking hard enough. Like we were born into this system. There's no way our minds don't have a fiat perception of reality. Fiat being the euphemism for just simply, you're in an incomplete system, you have an incomplete understanding. When you finally see a complete system and you still default to answering with the incomplete system's answers to explain the complete one, how can that make sense?
Yeah. Break free of your past memories and create the new, right? Like this is amazing, guys. Absolutely amazing. I want to highlight one thing. The conversation.
Can I jump in real quick, Preston? Yeah, no, just for me, and what this exposes, and what everything for a long time is exposed in Bitcoin is the stuff we talk about all the time. 8 billion people in service of 8 billion people. For your entire life, you've been told you belong here, and you believe that you belong here. You are part of a system, and Jack and Nick and Preston and all of the people that we love in this space are part of a system that is both contributing to a new system and is a part of, and every single person can move their time. And that's what this is observing. And so when we see these things, when we see these what seemingly crazy ideas, it adds to our proof of work and the knowledge and everything else, and extends our understanding. We change. And that's coming from that's coming from us. We are both parts of it. So it gives me shivers, same as you, to be a part of this crazy change inside of time, right? That we're a part of it. It's just it's so wild.
I love when you bring this point up, Jeff, because at the end of the day, you're talking about attention. And when you look at what has caused all these AIs to become so powerful with what it is that they're able to, it all came down to attention being the core thing that the humans unlocked in order to create this intelligence boom, right? And you're talking about that exact point, and it's like, it just makes so much sense that when you place your attention on where you want the world to go and how you want it, or like what you want that to look like, that you can pull that into the block that's being mined or minted, right? So excited, guys. And Jeff, I'm sorry for the handoff. We talk literally every day, and it just dawned on me that, yeah, you're a guest on the show and we're recording a podcast. And this is
That's okay.
that I'm having with you about other things. Where can people read the paper if they want to read the paper?
Yeah, well, Jeff has kind of pushed an accelerator pedal on us, and there's still a lot more work we're doing and a lot of refinements because, it would have been funny when we talked over summer. This would have almost been a lot easier to talk about, but there's just been so much more uncovered. And so there's so much more that could be talked about in terms of getting us to a timestamp of at least open up the conversation. We are now, at the domain bitcoinlens.net.
Okay.
That's where we're going to host it, and we'll make refinements, share updates, and show that process, and hopefully invite people to not just read the work, but if they have ideas, share it, point out like little errors, whatever you find. The place that they can find us will be the bitcoinlens.net.
You guys put up the boundary, and
Yeah.
everybody's going to come in.
It was hard to put it.
Apart. And you know what? This is wonderful because I think the influx of intellectual horsepower that you're going to get coming to this site, picking apart, for instance, if you enjoyed the entropy discussion and you want to see all the equations and all the hard work that these guys have poured into that and the energy that these guys have poured into it, it's in section 6 of the paper, right? So go to section 6, dig into it, find out why you disagree or why you think that there's additive information there. And this is a living, I'm speaking on your behalf, but knowing you guys, this is a living document. You
Exactly.
guys are more interested in truth than credit or any of that kind of stuff. And that's another reason I think Jeff and I are so excited about you guys putting this out there and getting this conversation going.
Yeah, we want to, with you guys, like literally, we want to create, the way we see it, I think, is like the collective white paper for the white paper that is that final global mirror of what is Bitcoin. Something I want to note is just we've had so many definitions of what is Bitcoin that's pushed the narrative forward that we've all, developed through, and we've thought, wow, like over and over again, Bitcoin is a peer-to-peer electronic cash system. That's the pinnacle right there. But over time, we've seen these lenses, windows. Bitcoin is time, as Gigi gave us, and then Bitcoin is digital energy, as Saylor gave us, and many, many other people have created all these different lenses. And so this is just an attempt to realize, like, wow, we can actually kind of pull all of those different lenses together to see the same thing.
Yeah, I just want to make it very clear too to the audience, like, we don't want to make this our theory or our paper. Like this, if what we're saying is true, like this is important for every single Bitcoiner to know and have. Like this is not something to be centralized and controlled. Like it's knowledge that deserves to be out there. So we don't want to claim like the absolute authority over this paper. It's just somebody needed to start the process and to kind of create the framework at which people can iterate from. So I'm sure you'll find, some things that you may disagree with or, you agree with, and it's like, bring them forward to us or help do the work. Cause it's like, this is an ongoing process of us really discovering like what we live in, like in terms of the universe and what Bitcoin is and how the two are related to each other. And it's really just the most fascinating time because I think this paper really just demands like all knowledge be reobserved through Bitcoin. And so it's like, there's a lot of work to be done. And so we need help, and we, just anybody can help doing whatever they see, however they can see it fitting.
The part of the show that I enjoy the most nowadays is here at the very end, we have this fun little tradition that we've started of taking the conversation that we just talked about and we turn it into a song. And then we play the song for the outro for the listeners. You guys aren't going to hear the song right now because we still got to generate it. But it takes all the stuff that we talked about and it turns that into the song. So I'm curious if either one of you, Jack or Nick, if you're really got a hardcore preference for an artist or a like music type genre. If either one of you guys has something, just say it. And that's what the listener is going to hear as we play the outro here.
Nick, do you have a preference?
For music style or an artist?
Style or an artist or even a song that you just love.
I'm a global lover of music. It's hard to pick a preference, but I try to find music that unifies the analog world and the digital world. I don't know, maybe there's a group called Odessa, and they're very good at synthesizing electronic and analog instruments into something that I think is a unique frequency that I think has absolutely impacted my ability to think about Bitcoin. So shout out to Odessa for helping this Bitcoin journey for me.
I wouldn't point to like a single artist, but I would just say like, I'm a punk at heart. And so like we're rocking the boat. And so, we might as well have fun with it.
I love it. All right. Well, guys, thank you so much for making time. We're going to have handles. Are you guys both on X and Nostr?
Just Nostr.
Just Nostr. Nick, how about you?
I have the handles. I've been off social media. And again, this conversation is a debate whether I engage with that, outside conversation that maybe will take place from having a conversation with you guys. But the tag, I believe, is Pleb Nick on both Nostr and X.
Okay. I'll have the links to Jack, Nick, and Jeff, obviously, over on Nostr. And we'll have the link to the website where the paper is going to be hosted. And guys, check it out. Enjoy the song.
At the threshold, everything's pending. Ghosts in a ledger, waiting for a witness. Waves in a lattice. All these may be worlds folded like paper, begging to be opened. States on standby, frozen in a shrug. Tiny coin flips, balancing on nothing. Your hand, my choice, hovers on a key. Collapse the shimmer, name what used to break. Time is not a river, time is a heartbeat. Pulse by pulse, the possible complete. Box of light ticking into being. All that we were, locked in the seams. Time is not a river, time is a heartbeat. Pulse by pulse, the possible complete. Moments don't flow, they shatter and link. Step after step on a disappearing break. Entropy and energy, spinning at the edge of memory, trembling on the smallest search where every truth is pulled. Entropy and energy, trading masks in secret holes, spinning out of fragile friends where maybe never falls. Time is not a river, time is a heartbeat. Pulse by pulse, the possible completes. Blocks of light ticking into being. All that we are, etched in routines. Time is not a river, time is a heartbeat. Pulse by pulse, the possible completes. Moments don't flow, they shatter and link. Step after step on a disappearing break. 0 point whispers under proof of work. Silent choirs under every search. Quantum fields hum beneath the proof of work. Click by click, we certify the world.
Thanks for listening to TIP. Visit theinvestorspodcast.com for show notes and educational resources. This podcast is for informational and entertainment purposes only and does not provide financial, investment, tax, or legal advice. The content is impersonal and does not consider your objectives, financial situation, or needs. Investing involves risk, including possible loss of principal, and past performance is not a guarantee of future results. Listeners should do their own research and consult a qualified professional before making any financial decisions. Nothing on this show is a recommendation or solicitation to buy or sell any security or other financial product. Hosts, guests, and the Investors Podcast Network may hold positions in securities discussed and may change those positions at any time without notice. References to any third-party products, services, or advertisers do not constitute endorsements, and the Investors Podcast Network is not responsible for any claims made by them. Copyright by the Investors Podcast Network. All rights reserved.
One of the uniqueness of asymmetry specific to Bitcoin is that if you don't take an action, no action is an action when it comes to your money that's getting destroyed. If you don't participate, your life will actually get worse off because ultimately your money is going to stop working. And what that means is not just that your purchasing power declines, but your standard of living declines.